All right. So going on, we've got a couple of topics we'll be talking about today, and again, as opposed to our normal sort of format where we are, we have experts or a panel talk about stuff. Today is really about use. And one of the things that we get asked often is, how do you use the Gemini tools? And again, Gemini is a very rich and diverse ecosystem, and we're going to be focusing on two of the tools today. And that is Gemini CLI, which is the command line interface to Gemini, which is really quite powerful, and it has a lot of capabilities that Gemini on the web that many of you might be familiar with, does not have. And Google Antigravity, which is the IDE that's based on Visual Studio Code, and it integrates Gemini as part of it, and it actually, streamlines your development workflow drastically. And we're going to be showing some examples about that. And so with that, before we get started into the actual tools themselves, I'm going to have my colleague Wyatt, give a quick demo. Wyatt, sorry, I didn't give you a chance to introduce yourself, so if you want to do that briefly before you get started.
Hey folks, yeah, my name is Wyatt Gorman. I'm the product manager on high performance computing, and I'm going to be giving you a brief overview of Gemini CLI today. There's much more to be covered, but we'll talk a little bit about it.
All right, so yeah, over to you.
So, thanks, Alan. So yeah, we're going to talk about both Gemini CLI and Antigravity today. So these are kind of two instantiations, two iterations of ways of using Gemini, basically. And we'll talk about the sort of similarities and differences of Gemini CLI and Antigravity, and the common foundation that they both share. Thanks for updating the slides. Awesome. So Gemini CLI on one side is sort of like an operator scalpel, I would call it. This is a headless, and by headless, I mean a terminal-based agentic tool designed as basically an ephemeral tool. It is a stateful tool, but it is, you'll see how it compares with Antigravity. It isn't meant for a long-term development interaction, basically. It integrates with your shell directly. It handles piping and streams. It can interact directly with files that you have on your system, interact directly with applications. And it's also very good for automating sort of infrastructure management and interaction with systems at the lowest level, either locally or via SSH, or basically in whatever way you're able to interact with systems from your own terminal as yourself. We'll talk more about how that works and what kind of capabilities Gemini has. Antigravity is basically like an architect's workbench. So think of Antigravity more as an agentic tool as well, but more of an IDE, right? So this is more of a tool for somebody developing code and looking for sort of asynchronous orchestration of code development. It manages a number of parallel agents that are then used to build, test, and refactor multi-file projects, complex projects. So think of Gemini CLI again as sort of useful for administrators, certainly for developers, but Antigravity more so as a developer's tool and an IDE. Antigravity does have the ability of interacting with your system and more than that of interacting with things like browsers. So it is also capable of some of the things that Gemini CLI is capable of, but in a slightly different way and for a different purpose. So in many ways, these tools can be used to achieve similar things, right? They're both based on Gemini and they both interact with Gemini, But then the way that they are oriented towards certain customer journeys and user experiences is very different. I'll admit right off the bat that I use Gemini CLI maybe in a bit of an improper way. I'm somebody who spends a lot of time in the terminal, and even when I am coding, I'm usually in Vim rather than in something like VS Code. And so I do even a lot of development and iterative development and even rather complex development using Gemini CLI rather than a tool like Antigravity, just because that's what I'm familiar with. But I'm aware that it might not be the best tool for the purpose, but it can be used for that. Similarly, Antigravity could be used, to write a sonnet, but it's not necessarily best purpose for that. So looking a little bit more in depth, Gemini CLI, like I said, a few things that make it really handy for administrative tasks and interaction with the system, but also for scientific workloads and things that would be useful for folks in the advanced computing community. So it interacts natively with SSH, so you can very easily access other machines, interact with remote resources like clusters and like HPC resources directly without needing to add any add-ons or anything like that. If the shell that you launch Gemini CLI from is capable of SSHing to a node, then Gemini CLI will be capable of doing the same, assuming you give it permission to do so. And everything you do in Gemini CLI is approved by you, so long as you don't turn on YOLO mode. Pipes intelligence means that you can pipe things to Gemini CLI. We'll see an example of that later, but that's very useful for ingesting files and logs and things like that. There are also a number of integrations with things like Pool Universe. So MCP servers are a concept that actually came from Anthropic, I believe. These are basically the ability to plug in knowledge bases and tooling into LLMs. And so Tool Universe is one of those scientific tooling specific MCP servers that we'll talk about a little more later. And then there are really a number of optimizations just in the way that you interact with Gemini CLI for sort of one-off, sort of lower latency, synchronous, sort of ephemeral tasks, like we'll show you a little bit later. But it can be used for longer running interactions, and I often do that. But I see the downside; it can lose track. Antigravity is a very different way of looking at it, and I'll hand it over to Adnan to cover that.
Cool, thank you, Wyatt. Yeah, so as Wyatt mentioned, Gemini CLI is great, and in fact, when I was trying to develop code, I would actually use a combination of Gemini CLI, put in my prompts, ask it to generate code, then I put it into my VS Studio Code, and then try to compile it and do all of those things, which works okay, but it's not the most streamlined sort of workflow. And that's where Antigravity really shines, is because it is based on Visual Studio Code. You can, not only use, Gemini as the AI intelligence agent behind it, but you can also use other tools like Claude Code and integrate it with your IDE. So, and what I'm going to try to demonstrate later is how do you do like a quick vibe coding example using the IDE. This is going to be a live example, so hopefully it works. But just again, for those of you who have not sort of really had a chance to work with Antigravity, it's really about having an AI agent integrated into your IDE, so you can ask it questions, you can ask it to optimize your loops, or do some loop unrolling. Ask it to compile it with different flags and see which gives it the best performance. And not only that, there's a whole level of automation that comes along with that capabilities, and you'll see some of that later on. But it is an IDE. That's its main purpose. It's got smarts built into it. It's got persistent artifacts. In other words, if you've asked it some questions and it's solved it, it knows how it solved it, and it can apply it to all of your future sort of workflows. And it's really, in my mind, a great way of demonstrating all of the capabilities of vibe coding that many of you have been hearing about and probably using, right? So okay, so the next slide, I'm going to give it back to you, Wyatt.
Great. So awesome. So both of these tools, like I said, have a common foundation, and the core of that is the latest Gemini models. Antigravity does support other models other than Gemini. It supports previous Gemini models, not just Gemini 3, but also supports Claude and other models. And in certain cases, those models certainly outperform Gemini, and I can attest to that. Gemini is what I stick with, though, and it works really well. Might take a little bit more iteration, but happy to see that through. Both of these, though, share the same capabilities based on those the Gemini models that they're based on, and a lot of that is really useful. I can elaborate later in the discussion, but I can give an example where the multimodal reasoning of Gemini, understanding the physical movements that I was looking for, and understanding image recognition really, really well. And having that all in a single model, along with the other capabilities of the application I was developing, was really, really important. And that's not something that I could do seamlessly with other models and other tools. MCP protocol is another key common fundamental capability across Antigravity and Gemini CLI. They both support MCP servers. And so bringing in tooling like the tool universe, like I mentioned, or tooling around MCP servers for Google Cloud capabilities or other cloud capabilities is a really awesome ability when you are interacting with cloud resources, like I often do when building silly little vibe coded games and platforms and websites and things, right? And then all of these are built on our enterprise IAM, and it's really easy to auth through OAuth or use an API key, and just get started and allow yourself to use multiple platforms, or allow your users to get started really easily. Do we want to stop for questions on that?
Yeah, let's. So I think we've given you quite a lot of information. So let's see. Do any of you have any questions before we get started on the demos? And we'll, again, the format for today's presentation is we're going to do the demos, as quickly as we can. But we really want to spend more time with our audience today and understand, how are you using these tools? What do you like about them? What do you don't like about them? Are there any, particular vendor tools that you like more? And so we'll do that. So if any of you would like to just if any of you would like to just sort of make a comment or share your impressions thus far, feel free to raise your hand. We'll put you on camera, or you can unmute yourself and just tell us about what you're working on. So before we go there, let's try to make this a bit more interactive. So how many of you have actually developed HPC code, say, in the past year? Okay, Samuel, I see. Who else? I see Michael, Revity. All right, great. So a lot of you. Okay, so you know what? I'm going to do it in order. I'm going to oh, where did Michael go? I think Michael was on and he. Okay, Michael, I'm going to let you unmute yourself, and or Mary, can you unmute Michael and let him speak?
Hi, this is Mike Haru. Can you hear me? Yeah, there you go.
Yes, I can. Hey, Michael.
Yeah, hi. Yeah, I've been an HPC person for about 40 years and have done a lot of programming of HPC codes, primarily in mathematical libraries directly, but then also with the Exascale Computing Project, being in charge of the software technology focus area for that, and then lately also with the Department of Energy, curating the stack of libraries and tools for the exascale system. So I do a lot of kind of overall management, but also still do a lot of code development and working with these tools. I wrote the HPCG benchmark source code, and so I've been playing around with anti-gravity and the HPCG benchmark, looking at low precision arithmetic, and have been quite impressed with the refactoring capabilities that anti-gravity and other tools as well have for helping me propagate changes across the source space.
Okay, cool. Are there any particular examples that you can talk about? I mean, you mentioned refactoring, but
yeah. So the HPCG benchmark was written for double precision arithmetic, but I've been going in and refactoring it to handle multi-precision. For example, one data type for the storage of data, floating point data, one storage type for the computation, and then one for the accumulator. And those can be different types, different bit precisions and different approaches. It could be bfloat, or it could be, FP, and try to understand the behavior of the code in the presence of those changes.
okay, cool. Well, thank you very much for sharing that, Michael. I really appreciate that. Is there anybody else who'd like to, chime in really quickly before we move on to the demos?
I'll speak up a little bit.
Hey, Charles.
Hey, Chuck Forsyth, UCR, Director of Research Computing. So I do quite a lot with Gemini CLI. Just like Wyatt was saying, I kind of don't leave it right now. I'm using it for practically everything I'm doing.
Mm-hmm.
I develop my own tools to help support HPC on campus. I develop like org charts. I have it help write files, write code, organize things, check my email, come up with what I'm going to do for the day, and then follow that. It really is quite a great tool to be able to do almost everything that I'm trying to do. And specifically for scientific computing and HPC work, we can do things like convert CUDA code into running on TPUs.
Right.
That's
how's
something.
that experience been? I mean, I'm sure, it produces decent code, but, what did you have to do?
Basically just asked it. I
Okay.
just said, hey, can you convert this CUDA code into to make it run on TPUs? And it said, sure. And it did it for me. And it said, do you want me to spin up a VM that has the TPU enabled to try it? Yes, let's do that too. So we can walk through basically everything. I think it's quite an amazing tool for researchers, especially if they can install it on an HPC cluster or something like that. You can do amazing things with it. You just basically ask about the science you want to do at this point, and it does a lot of it for you.
So Charles, hold on to that thought. What we're really going to be doing is showing you how to do that. I'll be giving you one part of an example, and then Wyatt's going to walk through another part of even setting up your own cluster, and that. Okay. All right. Very quickly, Sumit. Thank you very much, Charles. So Sumit.
Yeah, and then I actually, when you asked, Charles, on how did you do that, what did you do, I kind of picked up on that. In my experience, obviously, both of these mechanisms are great mechanisms, as long as you know what you want the tool to do, right?
Mm-hmm.
A quick example is I was exploring some fraud detection using our spanner graph API. And I gave it 6 million records, and I formulated my prompt fairly well, I think, and I gave it a target. Now, it will try to come up with a solution, but you have to guide the solution very deliberately on what is a maintainable solution, what is a good database query, what is a good version control mechanism. Like, you have to architecturally guide it really well. So I think that's where we still kind of have a job, I would say, as technologists, that you need to be able to guide this. A typical example, in that specific case, it wrote me a query, and I know that query is NP hard, and my compute is not going to be able to compute that. But that insight, it will not give that insight back to you unless you specifically frame or want it to go and research that area. And it will come back with a good answer if I tell it that, hey, this might be getting into a never completing or converging problem. So great tools, as long as I think the driver needs to still be a little bit conscious about how to drive these tools.
No, exactly. And I think that's a key point. So, I mean, the tools are great. I think they're productivity enhancers by manyfold. And that's the way, I've been using, because, and again, in this example that I'll be walking you through, it did a lot of things which I don't think I would have done, but I also, and I wouldn't do it because I just wouldn't know how to create a web page which had these things showing up. So I know I've kept you in suspense for long enough. So Wyatt, shall we move on to the next stage and press our luck and see how these things? Okay, yeah. Why don't you talk about this and then we'll get on to the next one.
Yeah, so we're going to go through a couple of sort of demo scenarios today with you. First, Adnan is going to go through rapid prototyping sort of scenario with Antigravity, where we're going to vibe code a physical simulation. And then I'm going to show you what it might look like to deploy similar simulation, that's a tongue twister, in a sandbox environment deployed with Gemini CLI. And then, in an ideal world, you might then take the output of your deployment or your Slurm logs back into Gemini CLI to identify any failures or opportunities for optimization, and to iterate on your code and your cluster deployment to further optimize your environment, right? So yeah, let's go ahead and jump in, and I'll hand over to Anna.
Okay, all right. So just so that everybody attending has a better understanding of what we're trying to do in this example. And again, this is probably more at the grad level if you're trying to do an initial simulation. And what I really wanted to demonstrate is how easy it is to code something that's actually quite useful. And in this particular case, since all of us are from an HPC background and have done interesting things, how about we create a simulation for an n-body gravity system, right? And with anti-gravity, of course. And this is really meant to be a vibe coding live demo. And hopefully things work. I ran out of tokens yesterday, so hopefully I have enough tokens to do this. And yes, even for people like Google, we do run out of tokens. And just a quick walkthrough of what we're trying to do over here is we want to create a prototype, using Python. It's going to be very, very simple and naive. And we want to walk through a couple of different steps to make it a high performance simulation. Ultimately, through prompts, I'm going to ask it to create a C++ version of the same thing. Right. So in terms of the steps that we're going to follow today, and if everything works out correctly, is I'm going to put in a prompt to create a simple n-body gravity simulation in Python. And we're going to, visualize the results for n is equal to 200. And that's really cool because, for me, I know how to write C++ code. I know how to write, really optimize it. But if you ask me to visualize it, using the browser, I'd probably be lost over there, and I'd be trying to figure out how these things work. But anyways, anti-gravity does all of that. And then I ask it to measure the performance, something that all of us are familiar with in terms of profiling the code, seeing where the bottlenecks are. And in this particular case, what it does is actually quite smart. It takes a screenshot of the simulation, and it actually measures how smoothly the particles are moving. Next, I ask it to vectorize that Python implementation using NumPy. And again, measure the performance, this time increase the number of bodies to 2000. And then lastly, I'll ask it to rewrite it in C++, measure the performance again, and increase the number of bodies to 5000. Okay. Sounds pretty complex. It'd probably take me, if I didn't have anti-gravity, it'd probably take me the better part of a day to do all of this. But I just want to walk you through the prompts because things, once we get into the IDE, things are going to move fairly quickly, but just so that you can follow. The phase one, as I said, here's the prompt: create a 2D n-body gravity simulation with 200 particles in Python. And you ask it to use Flask and HTML5 canvas to do the visualization. And again, I give it some extra information, where to run it and things like that. And once it's done it, I will say increase the particles to 2000, and then, you can see it's barely crawling along. And then it's too slow. Profile the code and tell me why. It instruments it, and then I ask it to optimize it using NumPy vectorization. And then lastly, I say like, okay, I'm going to increase the number of bodies to 5,000, and I want a certain, specified performance, rewrite the physics kernel in C++ and bind it to the Python. Okay, fairly straightforward. And, let's see if we can demonstrate this in a live demo. So I'm going to share my, hang on. Okay, so hopefully you can see my screen. So somebody sent me a quick emoji saying, letting me know. Okay, cool. All right. So I know it's a bit of an eye chart over here. Everything is cramped. Essentially, what I've done is I put those prompts, into sort of a text file. So and I'm going to go through the prompts one by one and have it execute. Okay. So
Adnan, can you zoom in, please?
sorry, what?
Can you zoom in?
Oh, okay. Hang on. Let's see. View. How do I zoom in on anti-gravity? I don't know. Appearance, screen. Oh, got it. Hmm? Okay. Yes. Is that better?
Yeah, if you could just go full screen as well.
Okay. All right. Okay, so just so that you know, I just I gave it the first set of prompts, which is start with a new directory. We want to do this n-body simulation and optimize it for HPC. Okay, and it's just setting up the initials, the environment, and it's setting up the visualization and things of that sort. Once it's done with that, we will then go through the prompts one by one. And you can see it's already started doing some of the things based on that initial prompt. It's created several files that you can see in my directory structure here on the left. It's and so on. And again, it's doing all of these things based on whatever it needs to do. And and here's the thing, right? Anytime it makes a change, anytime it does something, it asks you for explicit permission before it moves. If it before it proceeds, so you can see that. Okay, all right. So it's done the first phase now. All right. Let's see. Where is? All right. So I'm going to move this. So essentially, this is what it's created just from that first sort of prompt. And, and I asked it to put, I gave it some extra information that I want to have these 3 buttons, one to start, stop, and reset. So as you can see, this is 200 bodies. Let's try to reset it and start. And again, for my one simple prompt, it's managed to do this. All right, so let's move on to the next stage. Okay, so now that we've got that first stage, let's go on to phase 2. And you can just copy and I'll highlight it, and then you can put it in the chat and then sort of ask it to do that. And again, it's really cool at being able to, again, this really streamlines your workflow. And now it's working on phase 2, which is it's increased the particles to 2000, and just so that here, I'm going to show. Oh. Sorry, I'm trying to. The particle. Okay, so here it increased the number of bodies to 2000, and you can really see it's struggling to move them along, right? And again, that's exactly what we expected. 200 was fine, but anything more than that, it is going to struggle. All right, so let us. Oops. Okay, so let us move on to the next phase, and we're saying like, okay, we want you to optimize this using NumPy. This is my my prompt. I'm going to put it into the chat, and it's going to quickly go through it. And I apologize. It's it goes through this quite quickly, so you can't see it. But again, my objective over here is just to get you started on how you can do something similarly yourself. And for those of you who just want to use anti-gravity, and you can use your Gmail account, and it works great. In fact, for those of us from Google who have a google.com email account, that's not going to work. So you have to use a Gmail account for now. But you can always integrate it with some of the other tools that are available out there, like Claude Code and so on. Okay, so it's kind of spinning its wheels. It's rewriting the code in NumPy. Now, again, all of this is happening on the fly, and it's looking at the loops, and it's looking at some of okay, so now, oops. So here's the window. So you can see it's a lot better. Not still, it's still fairly slow and sluggish. But, in terms of the frames per second, essentially like, the iterations, it's like, 7 a second, which is not great, but it's still sort of, okay. So let's go on to the final step of this demo, in which case we want to write this code in C++. So again, I'm just going to highlight this. Oops. Where to go? This is into the chat and execute. All right, I'm going to let it do its thing. So it's going to look at, how is it going to implement this into C++? Again, not only does it have to do that, it also has to bind it with the Python code. So, it's still running Python, but it's ultimately, calling in the C++ subroutine for the physics kernel. So it's figured out how to do that. It's building it. It's trying it out. Okay, so want some permissions, I'm going to give it to it. All right, so I think it's almost there. And now it's analyzing the performance because I put that as part of my prompts. So what it did is it created a version. It looked at the performance and said, like, it's not, that much better. It's like 8 to 10 frames per second. So let's take a look again. So how smooth it is. So I'm going to bring this window back here. Reset it and start. So in this case, it's still not as smooth as I would like it to be. It's slightly better than the NumPy version. So again, in the, actually, what I would do otherwise is I would do add one more prompt and ask it to optimize it some more. But anyways, you get the gist of what, what I'm trying to do over here and how I sort of walk through this, to the process. So at this point, I'm going to stop this demo and I'm going to hand it over to Wyatt to let him talk about some of his demos using Gemini CLI. If that's okay. And in the meantime, again, if you have any questions, put it in the chat or put it in the Q&A. Happy to answer them. And, but okay, over to you, Wyatt. Hopefully I didn't take up too much time.
Mary, can you give us co-presenter again? Cool, thanks, Mary. So yeah, thanks, Adnan. So I think building the application is an awesome use of anti-gravity. I think that's a perfect use case for it. And I think if you were to get even fancier, you could have had that local browser window in a corner in Gemini, like you could in VS Code, and you could have all of this very nicely encapsulated in anti-gravity, and it's the perfect environment for developing things like that. On the other hand, I'm a little bit more of a systems guy, and I'm kind of more interested in, okay, so you've got an application, now how do you develop, how do you deploy that and scale it and develop an environment to run it in? And so I want to take sort of what Adnan did and deploy it, right? So Gemini CLI is the perfect tool for that. It's a really awesome sort of operator for science. Like I said earlier, it operates directly on headless nodes. In an ideal world, in an HPC cluster, you could have it on the login nodes. That way, it could interact easily with your job scheduler. It could interact with the storage that the user is able to access on their cluster, and you're able to access data locally without needing to move it somewhere like a local workstation or access it, over a network. Long distances. Gemini CLI is really nice, and Gemini overall is really nice for these kinds of use cases where you're looking to do sort of administrative tasks or to troubleshoot a code base or something like that, because it has a very large context window, so it can handle multi-gigabyte files, things like large log files or large code bases. It can orchestrate and interact with applications like Slurm, sbatch commands and Slurm sinfo commands and other things to interact with your cluster, to launch jobs, to interrogate the cluster about jobs, see the status of jobs and things like that. And it has MCP integration. There are Slurm MCP servers out there, sort of as open source. There are MCP servers for Compute Engine and things like that within Google, and you can expect to see many more MCP servers coming out for specific tools, both within Google Cloud and externally, to help integrate Gemini CLI even more seamlessly and capably with all of these sorts of tools. Gemini CLI has a few operational mechanics that I'd love to highlight for you in case you're not familiar with them. Interaction modalities, there's a couple of main ways of interacting with Gemini. The way that I use it is the interactive chat. So you can run Gemini and you'll be dropped into a sort of prompt chat environment where you can do multi-turn chat. That means that you can do all of the things that you could do with any of the other interaction modalities, just in a more stateful and chat kind of interface. That allows you to save state, share state. So we're going to use a couple of those capabilities, specifically the share chat state capability, to review some of the demo material that I have for you today. You can also pipe things to it out of standard out or standard error. And so you can pipe the output of commands, you can pipe the output of cat or anything like that to pipe files into it, and use it as you would any sort of intelligent assistant at the end of a pipe. You can also do one-shots, so you can just run Gemini and then a prompt and pass a number of things in that one shot, but just do this as a one-shot command. And that can be really nice for reminding you what a long, complex command might be or might have been in your history, right, or something like that. This can be actually really, really handy as sort of a universal command where you don't feel like finding the history or Googling the exact command. And then, like I said, there's session memory, so you can persist these sort of chats or the sessions across sessions, so that you can stop and pick up your work, or sort of pick up from a previous state, go back in time, kind of a thing, which is very nice when you're combining it with things like Git, which we'll talk about later. Authority and execution. So once you're in the Gemini environment, whatever environment you ran Gemini from, it inherits all of the sort of environmental properties and permissions of that environment. So all your shell variables, your paths, any applications you can access, any permissions you have, user level scope is basically how they refer to it. And that means that you can launch applications, you can SSH into machines, and so on. Gemini is even capable of doing sudo escalation and handing off or passing through the password prompt. So oftentimes in a Gemini chat, I will get prompted for a sudo password to install something or whatever, because Gemini might suggest that you go outside of Gemini to install it, but you can tell Gemini to do that itself, and it'll prompt you, for the password if needed. In terms of cloud and tooling orchestration, there are capabilities to directly call gcloud, AWS, command line tools, kubectl, all sorts of different things. And Gemini is very aware of all of these sort of well-documented public tools, even without using MCP servers. MCP servers help with accuracy and with understanding, and maybe with the latest and greatest features or beta features, things like that. But Gemini CLI is very capable out of the box. It's really handy for translating sort of natural language and plans and things like that into deployments, or into plans for deployments, and into things that other tools like Gemini CLI or Gemini CLI itself could later use. So we'll talk a little bit about planning and how to document planning for successful future reference and deployments. It's also very capable of interacting with popular HPC job schedulers and other well-documented tools, like I said. So if the documentation is available online, it's probably been ingested by these tools, and so it understands how to interact with Slurm and with PBS and with a lot of the popular job schedulers. And then finally, you can do context ingestion. So that means you can @ files, literally use the @ symbol and the file name, and it will parse the file that you're adding to understand it and to ingest it. You can localize URLs. So if URL, it can wget or curl that URL. You can also look at whole directories. And so this is a great way to review an entire code base or understand what's going on in a project plan. So a lot of the time, if I am picking up and I want to start from a clean slate, picking up a project, and I want to start from a clean slate, I'll just say, review this code base in this folder and explain it to me, identify what it's capable of, what its purpose is, all these sorts of things. And most of the time, I have several markdown files in that folder that have a lot of documentation that help the LLM understand what it's looking at. But it's very capable of going with that large context window and looking at an entire code base within a folder and all the files within that folder. I want to emphasize that what the demo is to focus on, and what Gemini CLI is really, really good for when paired with Antigravity, is sort of the outer loop work. So Antigravity, thinking about it as the inner loop of developing the application, iterating over that application. The outer loop would be Gemini taking that application and deploying it in some infrastructure that it can go and interact with and iterate on. So that's how we're going to use Gemini CLI in our demo environment today, and how I like to think about using Gemini CLI in pairing with tools like Antigravity. Gemini CLI is capable of deploying to anything, capable of using things like GitHub Actions. So we're going to use Cluster Toolkit and Google Compute Engine and things like that today, but I have done projects where, without any knowledge of my own of certain tools and without any MCP servers or specific prompting, I've had Gemini CLI go and deploy things in Firebase and data store and all sorts of different platforms that it is just capable of on its own. Right? So the kind of example building off of Adnan's demo that I want to give you or encourage you to think about is a sort of deploy and diagnose example. So using Gemini CLI, first I would think about deploying the workload that we have. So I would tell Gemini CLI, since it is unfamiliar with this code, it's not Antigravity, it didn't build the code and have all that context of that chat that Adnan was going through, right? I would first tell Gemini CLI, analyze the code at our nbody folder, right, wherever that is. Mm-hmm. And it might see that we've iterated over some Python code and some C++ code and tried to optimize, right? So it might have the context that we've been looking to optimize this code. And then I would tell it to set up a Slurm cluster or whatever job scheduler I would want it to use in my Google Cloud project, because I'm likely already logged into a Google Cloud project in my environment. If not, it would go and ask me, of course. Set up a Slurm cluster in my Google Cloud project to run batches of the nbody application with different parameters, right? And this is for you to elaborate on. You might have a file with different parameters that you'd want it to run, different numbers of bodies, different what have you, sizes of the space, and so on. But that is the extent of the complexity of the kind of prompt that you would really need to get started. That's a very simple example. I'll go through a real world example next, and I'll give you some tips that I don't even include in the real world example that I would definitely include. So these prompts get more and more complex as you build on them and as your own prompt engineering perfects. But this is the core of a prompt that would get you a Slurm cluster to run the application as desired, right? And I'll show you why I'm confident in that in the next slide. From here, once I have a Slurm cluster deployed that's running that application, I might have an error with my application that I might need to even go back to Antigravity to fix, right? Some edge case or some issue that I find, and so I could use Gemini in a piping scenario by catting the Slurm logs or the nbody application log or what have you, and piping it into Gemini and telling Gemini, to analyze the failed jobs and identify if any shared common hardware or runtime parameters or any other potential issues might be causing that problem, and to diagnose that, right? I don't do it here, but you could pass with that either in the prompt by saying, understand that this job is running this application at nbody. You could have it go and look at that context. You could pass it context from other chats. There are a number of ways of expanding that context as well. This is, again, a very simple sort of workflow, but this is the kind of workflow that I know a number of users are doing in their own HPC environment, and that I'm doing in my own development today, and building blueprints for specific applications and things like that. These are the core sort of prompts that you build on. In the real world, if you were at Supercomputing 25, or if you've seen some of our demos recently, we've been giving this sort of a real world deployment prompt to people, and showing how successful it is, right? So this is a molecular dynamics sort of deployment, where effectively I'm looking to run the GROMACS application, the water GMX50 bear benchmark, on a simple Slurm cluster, right? And so I would give it the prompt to act as a cloud infrastructure engineer, maybe act as an HPC cloud infrastructure engineer, provide the Google Cloud CLI commands and the minimal configuration needed to deploy a Slurm cluster using Cluster Toolkit. Here are my requirements, right? Use the pre-built Slurm GCP and GROMACS blueprints from the official Slurm Cluster Toolkit repository. The configuration should be as simple as possible. Use a simple machine like a C2 standard 4 to avoid GPU quotas. Provide the gcluster deployment command necessary, and keep explanations brief, right? And from there, it does spit out a set of 3 or 4 steps and all of the commands and a simple blueprint that would give you, exactly the environment that you would need from all appearances, right? And from there, and I'll show you that example, but from there you just say, go ahead and execute the commands you provided, right? You could say, provide and execute in the prompt, but this gives you the opportunity to review what it's done, and before it just goes and runs something, to give your thoughts on it and an opportunity to interact with it, right? Throughout all of these stages of Gemini going through and working on this, it will prompt you to approve what it's doing. Sometimes it can get tedious though, and so sometimes I'll turn it on to YOLO mode and say, check with me before you do anything, right? And YOLO mode is something where it doesn't ask if it can do something once or every time. If you're familiar with Gemini CLI, you'll be familiar with it. I mean, you can just let it go and run free, kind of. So what I did was I went ahead and, I'm going to show my screen, and ran that prompt verbatim earlier this morning. Actually, not long ago enough, unfortunately, but I could show you where we are. So this is, and tell me if you can't see my screen, this is Gemini CLI interface running in a sandbox environment that I have. And so you can see I've canceled the prompt, but this is just to show you that this was just running earlier. What I'm going to show you is actually the output of a chat share command. And so chat share lets me share the current conversation to a markdown file. So I'm just going to go over here, and this is the markdown file that I exported just an hour or so ago. This is basically a full view and capture of the entire interaction with Gemini CLI. Everything it's thinking, everything I've said, everything it's said back to me. Things that I never get to see because, as you saw with Adnan's example, it moves way too fast, right, to see sometimes. But that's, this is the full file. And basically what I want to show you is I start, not up here, this is actually, if you see the first few lines, or this is the Gemini CLI, setting up the context for our chat. The day is blah, blah, blah. My environment is, and so on. So I'm going to skip past that. My first interaction with it, and the bulk of my interaction with it actually, was act as a cloud infrastructure engineer, provide the specific, like I said, the exact verbatim prompt that I had provided to you, right? And what it did was it immediately went and did a web search for cluster toolkit, GROMACS blueprint, and it found the GROMACS blueprint is located in the cluster toolkit GitHub repository. You can find the specific blueprint at HPC Slurm. So it already found in the first turn the exact blueprint that I would have taken, several minutes to email somebody to point them to, right? It understands that what the blueprint does, and it cites its sources, and then it responds to me and says, I will create a minimal GROMACS YAML configuration that deploys the Slurm cluster and starts spitting out the blueprint, right? And that's already 90% of the work, to be honest. If you're familiar with cluster tool, once you have the blueprint, you're there. And from there, it's just going ahead and providing me the commands that I would need, right? Step by step, deploy the cluster, submit the benchmark, and so on. And then I just say to it, execute those commands. And from there, it goes on and runs it, right? And so we're at the SPAC install stage right now, actually. But if I switch over here, I can show you. These aren't actually them. I've got to switch my search. It's got 2 nodes up, that I never told it to spin up or like explicitly, never told it how to spin them up or anything. But it's got 2 Slurm nodes up, login and a controller node, and Slurm is running, and it's going and installing GROMACS from compiling it from source. So it's it's something where very little need to educate yourself and spend hours and hours researching all of the components that would be needed to do this, or for your users or your researchers to do that. They can interact with Gemini CLI, and even without MCP servers or any special tuning or configuration, with a fairly simple prompt, you can go and deploy a real-world application and get real-world results, right? In a very short amount of time. So,
all right, Wyatt, we are out of time, actually.
I'm sorry to say. Why don't we go?
Why don't you wrap up really quickly? There's one question. We'll be a few minutes over, and I apologize, but yeah.
Yeah. Thanks, Mary. So, just to give an example, from there, I might, iterate on this by saying, okay, well, if I am developing a new application and deploying it, or developing a new cluster environment, I might take my Terraform logs and pipe it into Gemini and have that iterate and fix my deployment. And then I might have Gemini go and feed that back into my GitHub repository, right? And evolve my project and iterate on it. So it's not just a develop and deploy kind of a pipeline. This is and should be an iterative pipeline and a back and forth kind of motion with these tools. So I'll just leave this on the screen for anybody who's interested in reading it later. And yeah, why don't we wrap up with that?
So yeah, Eddie, you've got your hand up. Why don't you quickly ask a question? I'm going to wrap up after that. So.
Eddie. Oh, hey, this is a great, thanks, Wyatt. That was really cool. In terms, like, I have a similar flow. I mean, I'd say I do more, what's what I'm looking for? I do both. I do a lot of CLI, and I also do a lot of IDE in the development phase. And one of the things I love about Antigravity and Gemini CLI is how integrated their kind of like sub thing is. So example is like your prompts that you do, when you did that, do you put those all like in like a Gemini MD file in that project? You have like a global, and in Antigravity, the great thing is like any global rules you create in Gemini, the .Gemini folder or in your workspace, they kind of flow into both the CLI and Antigravity. So I put them all there, and I've been noticing the thing. But like, is that how you use it as well in terms of like putting all your prompts and things like that, creating agent skills?
Wyatt, you're on mute.
Okay. Sorry. Yeah, 100%. I skipped over it at the bottom here, but within tips, I say document your plans and rules, right? So absolutely, I in all of my projects end up with a whole bunch of markdown files that define what the project goals are, right? What my target outcomes are, what the implementation plan is, and stages, and implementation notes, and checkpoints, and statuses, right? And then rules about how Gemini should act, right? Always checkpointing within GitHub and all of these sorts of things, or Git, excuse me, and all of these sorts of things, right? Yes, 100%. Implementing all of those sort of rules and instructions are absolutely key to successful.
Yeah, it would be great for us to start like an internal, like awesome anti-gravity / Gemini rules, skills, or something like that, so that people can like share them. Because I've seen like so many people have different ones, and it'd be like, I have one just for writing executive briefs. I have one just for better prose writing. I have one for doing feature and PRD help, you know, like, so it'd be great if we had like an internal, either an internal or something even external, but like something we can do where all of us can share some of these great rules that we're all putting together. So thanks.
Okay, one last question, Daniel, and then we will wrap up after that.
Hey, hi, I'm sorry, so I pasted my question in the chat. So I love Google because it always meets customers where they are. Over the last year, I'm heavily invested into Claude Code, and I need to bridge the gap without switching properly. What are the workflows and patterns for integrating the two? Because I always have to fact check Claude Code for architectural decisions, and Gemini is much better, but it needs to be transparent, not cutting and pasting between the two. How would you bring me over? Like, what are the patterns?
I mean, I'm done. Feel free to jump in, but yeah, then I think you're looking at sort of a multi-agent, multi-platform orchestration tool, right?
Yes.
Outside of either of these tools, there are a number of them. I don't have any experience enough to guide you on anything. Does anybody else?
Yeah, does anybody in the community have any experience with that? Because unfortunately, Daniel, I haven't had to do that, although I think the need is arising for me because I do want to compare Claude and Gemini, but unfortunately, I don't have anything on that. Maybe we can do it offline.
Yeah, in that case, I can help the other guys. Like, I know you can install Claude Code extension through Antigravity, but I'm already using VS Code with Claude Code extension. So I run you as Gemini CLI, but it's like two code bases. Sometimes I access this model through GitHub Copilot, but it's not integrated. So most of the time I'm cutting, pasting between Gemini app and back, like criticizing, Gemini says so. And so having them fight between one another, but it's time consuming.
Yeah, and before Antigravity, I was doing that with Gemini CLI and the web version of Gemini, copying and pasting stuff into my ID. But unfortunately, we're going to have to wrap it at that again.
No problem.